Well, I just got done watching the Packer game, and another season ends at the hands of the 49ers. I hate you, 49er people. Not really. They actually got farther than I expected, so I guess that's a good thing. Also, the head cold continues. That's fantastic. Whatever. So this week, and for the month of January, we're actually going to be doing something different. I'm a fairly active member of the muffwiggler.com forum system, which is where a lot of people that are into modular anything, modular hardware, modular software, it's where we kind of hang out, trade gear amongst ourselves, trade tips and techniques, and also get a chance to talk to each other about modular systems. So what I'm going to do this month is kind of use the Muff Wiggler viewership as a benchmark for who I should talk to, and we're going to start off with a couple of interesting interviews. This week is Paul Schreiber, who is a hardware modular developer. Next week we're going to be doing Randy Jones and his work on both the interesting sound plane device as well as his Alto and upcoming Kaivo software. Then I have a couple of more surprises in my pocket for the weeks after that, assuming that I can get the people on board. But nevertheless, that's what this month is going to look like. It's a little bit different. It's not going to be super Mac-centric, but that's okay. We need to really embrace the entirety of the media art space. So, and if you're not into music, don't give up, because there's actually a lot going on in the modular world. It's not just music oriented. So I would beg you to continue to keep a listen to the site. So, without further ado, let's get into the interview. Okay, in today's podcast, I'm going to be talking to Paul Schreiber. Paul is the main man behind Synthesis Technology, which is a module maker. He developed the MOTM system way back in the day, and it was a phenomenal system, groundbreaking in many, many ways. But he also is doing a lot of really interesting work, and I thought it would be really great for us to spend a little time talking to him. Hi, Paul. How are you doing?
Hi, Darwin. Thanks for having me.
Sure. I'm really pleased that you're willing to take some time from your busy schedule to talk to us. Why don't we kick this off by having you give us a little bit of your background?
Sure. I came from a family where my father was a nuclear physicist, so I was always around science stuff. But when I was in high school, I was interested in being a chemistry major. So I didn't do much electronics, except I just liked listening to my stereo. But I didn't really do any kind of soldering and stuff like that until I got to college, and that was because I had to change my major from chemistry to electrical engineering, because I had to have a PhD in chemistry to get a job, and my mom had two daughters behind me, and she wasn't going to pay for my PhD. So she basically enrolled me in Double E because she said, and I quote, "You like to listen to your stereo." So that was how I wound up being a Double E major. And since I didn't have the math background, Double E was pretty much of a struggle for me in undergraduate school until I got a copy of Electronotes. So a roommate of mine had a friend who had an extra spare copy set of Electronotes. He gave them to me. I started reading them, and that's really got me hooked on thinking about synthesizers, was reading through Electronotes. So during my junior and senior year, we had to have design projects, and so I would look through Electronotes and pick some circuits out and build those in the lab. And that's kind of what got me interested, back in the 70s. I'm showing my age here, being back in the 70s.
Right, but it's interesting that Electronotes pulled you in. That was really influential to a lot of people. Were you just subscribing right from the author?
Well, I started subscribing, I believe, with issue number 63, which, if for people who don't know what Electro Notes is, it was a PhD candidate who was mailing these out. He hand typed them, a guy named Bernie Hutchins, and he mailed them to you for like, I think the subscription back then was like $5 a year or something. And he would type your name and address on the cover of every issue if you're a new subscriber. And I will say that me and Bob Moog both have our name on the same page as being new subscribers. So I thought that was cool. I actually had that on my wall for many years. Like, look, we're equals. Only in my mind, okay? So I started subscribing around, I think Bob and I joined around issue 62 or something like that. And then I subscribed all the way to the very end. I never missed an issue. I bought everything he had. I read every page of that thing probably 50 times. He still sells it, by the way. I think it's $250 to get everything. And I continually encourage people to buy it. You will not get more bang for your buck than buying Electro Notes. Now, you have to understand that it was done when a lot of the old parts were still available, like the CA3080, which you can no longer get. So you have to understand that you just can't copy everything in there. But that's not the point. The point is not to treat it as a cookbook. The point is to treat it as a food science book.
Right.
So I kind of put that aside after I graduated. When I graduated, got married, I had children. I worked in electronics as an application engineer for companies like Cirrus Logic and Maxim. I did analog design mostly. I did do some digital DSP work in the telephony business. But I really wasn't into synthesizers up until I started MOTM. And that was in the spring of 1998 is what got me interested. And what got me interested in that was stumbling across the Analog Heaven mailing list.
Right.
Right. And so I kind of and I was a very internet neophyte, okay? I wasn't on the internet all that much until I learned about that list, and I jumped in with both feet. And for those of you who followed my activities on the Analog Heaven mailing list with people like Mike Peake and Kevin Leitner, it kind of started off, shall we say, badly.
There was some contention, at that time.
Right, at that time. And I'm partially to blame because I misjudged the people who were on that list. I thought it was more of a technical list, kind of like CompSys DSP or something on the Usenet group, not a general purpose kind of list. And so that kind of ironed itself out over the years, but it kind of got me thinking. So what I thought about doing originally for MOTM, and of course people knew that MOTM stood for Module of the Month, was to do a new version of Electro Notes where you subscribed, and what you got instead was you had a blank PC board with instructions, and then everybody who subscribed would, build their own synthesizer.
Right.
And that's how the vision of MOTM started. But unfortunately, I didn't have enough time to do that, so I had to go another direction, which was to offer, kits en masse and not have a subscription kind of a level.
What kind of a job were you doing at that time? Because I remember when it came out, you hit those first several months flying, and I was like, wow, is a guy really able to do this as a full-time job? And it's clear that wasn't the case. What were you doing for work at the time?
Okay, so at the time, I had a job where I was a field application engineer, but I worked at home. So it was mainly tech support and all done through email, but I was at home.
Right.
And what I would do is I would get up in the morning and check my email, and most of my customers at that time were in Asia, in California, and I was based in Texas.
Okay.
And so I would basically be done by 1 o'clock in the afternoon. I would be done. And so once I was done, I could do my synthesizer work.
Sure.
And, I had the email notification. So when an email came in, I'd go bing, bing. I'd stop what I was doing. I'd go over and check the email. But I was able to do both, basically, time sharing between my regular job and doing MOTM. Now, I started MOTM. The only feel I had were the people on the analog, heaven mailing list. Okay, I didn't, Musliger wasn't around. So I decided, to go very cautious. I'm a very conservative, cautious person by nature. Okay, and so I said, well, maybe I'll build a couple of hundred in a couple of years. And I grossly underestimated the demand, which has been my claim to fame, I guess, for the last 15 years. Is grossly underestimating the demand versus my free time, which as my children got older and my jobs changed, my time compressed.
Right.
But I haven't seen the demand drop off in general in the last 13 years, which is really good. A lot of people say, well, why don't you just stop doing that and do that full time? And the answer is health insurance.
Right, of course.
Because I'm married and my wife doesn't work and I had 2 children, I had to have health insurance for 4 people. And I did look around, I would call the various health insurance, people and get quotes, and they're outrageous. I mean, it's around $2,000 a month,
right,
just for the health insurance. And although the demand was high, I priced the MOTM not to be sufficient for a full-time job. So people who are interested in getting into the business, here's the rules of thumb. If you take your parts cost and double it, you won't make a penny.
Right.
All you'll do is, it's called pinball. If you read the book Soul of a New Machine, won the Pulitzer Prize about when I worked at Data General building computers, the phrase was pinball, which means if you do a good job, we let you do it again. And so if you double your price, you're just playing pinball.
Right.
Okay? You won't make a dime. If you triple your price, you have enough money to hire yourself part-time and buy toys. Okay?
Right.
So you can buy a new oscilloscope, you can buy some new monitors, you can buy some new headphones. If you quadruple the price, you can have 1 part-time employee, and so on. And so for MOTM stuff, it was a doubling. I just took the bill of materials and doubled it, and that's what I sold it for, because I was just interested in keeping doing it. I had enough volume where I could, buy a few toys. I took my wife to Hawaii twice and that kind of a thing, but it wasn't enough to stop what I was doing, pay for the health insurance, and then still make a reasonable salary. It just wasn't that way. There are times when I daydream, and I'm certainly jealous of people who are able to do that. I can tell a jello and make noise. But I personally have not been in a position to be able to do that.
I think that's a common issue though too, and you see sometimes people get really excited about a new venture, drop everything to run off and do it, only to find that perhaps the business isn't there to support them full time. And the problem is by not being conservative, the business ends up going away, which doesn't really serve anyone's interests.
Right.
Where your very conservative approach, it makes it so that you've been able to maintain a pretty good business for a long period of time.
Right, and I do that on the grace of my customers' patience. Okay. And I've got the best customers in the world. Now, I'm sure I have my detractors, and some of them have sent me some really entertaining emails, including one, recently. But the thing is that I've always been upfront about it. I've never tried to hide and stuff like that. Now, do I break promises? Yes. I'm probably known for breaking more promises than anybody. But generally speaking, it's because something has happened, in my personal life, I've had some recently in the last 5 years. Last 5 years, I've had 3 job changes, including having to move from Texas to Arizona.
Right.
And so I've had some very disruptive things happen to me starting about 2008. And so hopefully I'm going to try to get those behind me, knock on wood. And so 2014 looks like I'll be able now to get back more full-time. My children are now in their 20s. I'm a, quote, empty nester now. And so I'm hoping to have more, free time to do that. Of course, my wife will probably want me to, spend time with her,
Well,
she's not into this at all, by the way.
Yeah.
Zero. Absolutely zero interest in what I'm doing here.
But I think that's probably wise. My wife is not into any of this at all. She respects that I like to do it, but I think by having things that are different allows the relationship to maintain some enjoyment. So.
Yeah, so certainly my wife understands that the money I've made from Eurorack, is very beneficial. And the reason that's beneficial is I went from trying to do everything myself to having a distribution network and then doing most of the assembly, out, farmed out.
Right.
And that's the one advice I tell everybody. Okay, I say, do not think you are, quote, saving money by doing it all yourself. You are losing money. You lose money because you can't produce it fast enough. You lose money. I said, you get it quoted out, you write checks, then you go to Sean and you say, hey, Sean, this is how much it's going to cost you. Sean says, fine, and you make Sean pay for it. Sorry, Sean, but that's how it works, is that you make your distributors pay you for your time and effort.
Right.
Okay, if you think that you can sit there and hand solder 50 kits on the weekend and make yourself miserable, okay, you're not helping yourself or anybody else. And I'm surprised, I'm not going to name names, but there is somebody who's in the upper echelon of Eurorack stuff who still hand solders the stuff one at a time, and which is silly because there's thousands of people out there desperate, to bid on your business for doing
right.
the surface time assembly. And again, you don't pay for it. You make your distributors and your customers pay you for it.
Right. Well, I think that people don't understand sort of the difference in the ecosystem now versus what it was like when you were first starting. I remember when I was working with he who shall not be named, it was very difficult to find someone who would do small runs of circuit boards or small runs of faceplates. And if they would do small runs, they would charge an arm and a leg because they were used to getting quotes for things in 5 and 10,000s. And so when someone would come and say, well, I need like 50 of these, they were sort of like not sure what you were even talking about. So the kind of background system to help things move forward and it just wasn't there. But also the idea of there even being modular distributors like what Sean's doing with Analog Haven and some of these other folks, the Schneidersboro people, none of that system existed. So the person who was putting together the modules also was having to pack them and ship them and do the bookkeeping and keep the order backlog and all that stuff. There's a tremendous amount of extra work that had to be done in order to pull that stuff together.
And I think what happens is people get excited about the fact that they're in the synthesizer business, and it's exciting to be in the synthesizer business, especially if you sell to somebody famous, okay?
Right.
Like, Hans Zimmer bought something, or, in my case, Trent Reznor bought a bunch of stuff or something. But the actual synthesizer R&D and building is 5% of the business. I mean, you got to spend hours doing with mouse or DigiKey buying parts, tracking stuff on UPS, buying boxes. Oh my God, where do the boxes go? Oh, I'm out of tape. I can't tell you how many times I ran out of tape on a Sunday night. That kind of a thing. And it's just it becomes a job. Okay, your hobby becomes a job. Now, I know I like David Dixon IntelliGel. He calls it a jobby.
Right.
It's a hobby and a job. It's a jobby. And what happens, that takes time away from everything. But again, you can't really hire somebody, to do that. But you're right. I think the biggest single thing which has been an impact in the last 3 years to be able to do this, more cheaply and efficiently is the combination of having cheap Asian-sourced circuit boards available and having cheaper PC board CAD alternatives available.
Right.
When I started doing MOTM, I had to buy a full-up version of OrCAD for the schematic capture and a full-up version of PCAD 2006 from Cadence, and those two things combined were $18,000.
Oh, man, that's unbelievable.
And I paid $18,000 for that. I paid $16,000 for an audio precision. I paid $4,500 for a scope. Okay, it's a very expensive business. Okay, back then. Okay, the other thing which is cheap is eBay. All right, so all these expensive pieces of test equipment that were literally tens of thousands of dollars, you can buy today on eBay for $200. Okay, which is just jaw dropping. I mean, my $4,000 analog scope, I saw it on eBay for $225 yesterday.
That's amazing.
It's 5 cents on the dollar to buy this high-end Hewlett-Packard Tektronix test equipment. Okay, so the test equipment is cheap. Circuit boards have dropped by a factor of 10.
Right.
Even in low quantities. Okay, and then the CAD software, I encourage everybody to use a program called DipTrace. It's done by a bunch of crazy Russians over in Russia, but it's a great program. It's free. You can download it, and I know a lot of people use Eagle, but I like to use DipTrace. And the CAD tools are free. They're not $18,000 anymore. And if you need to actually play out some decent boards, I think I bought the high-end DipTrace. It was $400 or something.
Right.
So it's a huge difference. And then you have metal photo to do your front panels and stuff like that. So it's very easy to be in the module design business today, much easier than it used to be. Now, the problem is, that you kind of alluded to, is that if you have your copy of Electronotes and you use Electronotes as a point of reference or use schematics for the old classic synthesizer as a point of reference, if you don't understand the designs in there and you just try to basically use them and build them, half the parts you can't get anymore. And so it becomes a real challenge today is how do I build something that I can actually buy parts for? And the answer is you just can't look at something and try to copy it. You have to understand.
Well, that's
what I encourage people to do. You have to understand what it is you're doing, and if you understand it enough, then you can say, well, I don't need that exact FET. I can use this FET over here.
Right. Now, one of the things, and this brings up a really interesting area that I'd like to explore a little bit. Right now, there's this whole movement really kind of based around like Make Magazine and this whole Maker Faire thing, which is sort of oriented towards learn a little bit about electronics, the availability of the software and the, as you alluded to, the test equipment. The availability of this stuff at a reasonable price is out there. So get out there and hack and play around and do stuff and make stuff. And it really encourages people to go out and sort of like break through that initial barrier and try something. And I think that's phenomenal. But
the barrier of entry to electronics has always been high. I mean, when I was an undergraduate in EE at Texas A&M, this is like, say 77, 78, 79, my dream was to have my own scope.
Right.
All right. And back then, a used Tektronix 465 was about $1,800, okay? My father made $1,800, and that was 3 months of his salary.
Right.
Okay, so can you imagine a modern person in your job today saying, well, a used oscilloscope is 3 months of your salary. All right. Well, you can go on eBay today and get a $10,000 Tektronix 2465B for $400.
Right.
One of us new was $20,000. It was $20,000.
Right. But now with all of this stuff available, the one thing that seems to be missing, and particularly in the music electronics area, but I think in electronics in general, is sort of the next step. So it's like, hey, I went in and I soldered some things together and I made an Arduino blink a light or whatever, but now I really want to go through that process of learning to understand. Do you think that any of that understanding process has gotten easier versus when you were learning?
No. And here's the reason why. Okay, the process has been the same for 5,000 years. Okay, and it all depends on you have to want to do it bad enough to do it. And I think that's where a lot of people have an issue. I tell my children that college is hard because it's supposed to be hard. And that's true with learning electronics. Okay, it's hard. And it takes a long time. And believe me, when I was switching from chemistry to electronics, I remember one test I made a 5. I mean, the number 5 on a test. Okay. But the difference is I didn't quit and I didn't give up. Okay. And, when I graduated, there were 62 people in my graduating class. I was ranked 33rd. So you could say I was in the bottom half of my graduating class. So, you don't have to be a straight A student. You just have to have the initiative and the drive. And basically what I did was I'm not going to give up. I'm going to figure this stuff out.
Right.
And what I used was I had Electronotes in my lap, and I had Larry Fast's first Synergy album on the stereo, and I said, I'm going to figure that out. I don't have to make an A, but I'm going to figure it out.
Right.
And it takes a long time, and I kind of see this a little bit when I look at demos that people do of their systems. Okay, they go, look, I just got this great patch, and here's a little video I'll put on Vimeo, and watch it go. And I look at it, and I watch every single one. Okay, I'm like a synth demo junkie, and I click on it, and it goes, and I go, what the hell is that? Okay, I'm like, look, that's great, but why don't you think about doing about 2-part invention? People go, well, that's boring and stuff. I go, no, because what you need to do is you have to learn how it sounds that way. And I think that's what a lot of people don't understand is that they need to go from simply looking at everything as a cookbook. So in our world, we call that being a technician. Okay, a technician is somebody you can give a schematic to, and they will build it, and it will work exactly, and it's nice and pretty. I work at Microchip, which is a big microcontroller. We have some great technicians, and they do surface mount work with 0402 resistors, and they build all these 10-layer test boards, and they're perfect. I couldn't do it if you paid me.
Right.
Okay, but those technicians literally have no idea what they're building. Okay, none. And we have technicians who've been there for many, many years, but they haven't learned it. They can do it, but they haven't learned it. And so that's what I encourage everyone to do who's into SDIY, is move from doing it to learning it. Just understand it's going to take you years to do it.
Do you think...
I've been doing this 38 years. I'm still learning stuff.
Do you think that still going back to Bernie's Electronotes is the best way to kick that off?
Yes. There's nothing better.
Awesome.
There's absolutely nothing better. If you're trying to figure out why is this a filter, okay, which is probably the hardest thing to understand.
Right.
Why is this a filter? why is this an EGA, VGA? Why does, this circuit make a high pass instead of a low pass? Why is this op amp better than that op amp and stuff like that? And the other thing is there's so much stuff on the web now that, for example, MIT has every single EE class and undergraduate free on the web. Every single class at MIT is free on the web. Now, it's all up in a boring PowerPoint, and you have no narration. But I'm saying is there's a lot of stuff out there that you can do. And that's how I learned. Now, everybody's different, but I think that's how people should do it.
Sure. Well, and again, it really it has to be backed up by that passion of saying I'm choosing to learn this, and no one can prevent me from doing it. A certain amount of that is really required. So let's go back to the creation of MOTM, because MOTM. I really have some questions about it because I'm fascinated by what you did, and I'm fascinated for a couple of reasons. First of all, it's very clear when you look at the units, or when you start speccing out a system, all of the decisions that you had to make. And I know from working with artists and technology people of all different stripes, that one of the things that everyone is interested in is how other people make their decisions. And when I look at the MOTM synthesizer platform, I am overwhelmed by the number of decisions that you had to make in some finite amount of time. How do you decide, how do you make those decisions? How do you approach that decision-making process to say, I'm going to use metal of this thickness, or I'm only going to use switchcraft parts, or I'm going to have things laid out in a certain kind of grid? What was like your internal monologue as you were making those decisions?
Okay, well, it's essentially a two-part process. So the first thing I did when I decided to do this was I got a large piece of engineering paper. We actually used to have drafting. I actually took drafting in college, and we used to have these pieces of paper that were 24 by 36 inches, on grid, very large piece of paper. And I got one of these large pieces of paper, and at the top of the paper, I wrote, what Bob Moog didn't have. Bob Moog, when he did a system in 1968, he was an absolute genius dealing with what he had at the time as far as technology.
Yeah, what he was dealt, the cards he was dealt.
Yeah, the cards he was dealt. I mean, he had to use certain transistors because there wasn't that many to have. He had to use Allen Bradley Type J pots because that's all you could buy. He had to use switchcraft jacks because switchcraft was the only place in America that made jacks and things like that. And so I knew what he had, so I wrote a big piece of paper and I wrote what he didn't have. The first thing I wrote was LEDs. Everybody knows I hate LEDs, but Bob Moog didn't have LEDs. Then I wrote CAD software. He didn't have CAD software. All right, and so on. Okay, surface mount, 1% resistors. I mean, we think 1% resistors are no big deal. All right, I mean, 1% resistors now you can buy them for about a penny a piece or something.
Right.
In 1968, 1% resistors were about $9 a piece. That was $9 in 1968. Okay, and even when I was at Tandy doing modems and stuff, I needed a 1% resistor in my filter, and high volumes, like millions of pieces, 1% resistors were around 18 cents a piece. Okay, but you need 1% resistors, not because they're accurate, but they don't drift with temperature.
Right.
And so things like that, and I had this big long list of what Bob Moog didn't have. And I decided to do something like a Heathkit. Now, Heathkit, for all you young people, was a company in the 60s and the 70s that made DIY kits of everything from color TVs to shortwave radios, and they were known for these beautiful illustrated manuals. And if you had a Heathkit catalog, their big shtick was the first page was their color TV with a woman who said, "I'm a housewife and I built the color TV." Okay. So I wanted to be like the Heathkit of the DIY world. All right. And so I built many Heathkits in my time. And what Heathkit did was they tried to make it foolproof. Now, when you make something foolproof, it costs more. All right. So what do I mean by foolproof? Okay. Everything from the size of the holes the parts go in, you make them bigger than normal. Okay. Make the holes a little bit bigger. You make the pads a little bit bigger. You make the copper on the board a little bit thicker. You make the parts spread out more. Okay? Because people who've never built before, you know, they're going to get freaky if, like, the parts touch each other.
Right.
Or I made sure that everything pointed the same way. Okay? All the diodes point the same way. I never had one IC point differently. That's because you knew instinctively that if it pointed the wrong way, it was wrong.
Right.
Okay? Whereas in reality, you put parts all over the board any which way you want to because nobody cares. Okay? But if you're building it for the first time, you want everything to kind of not. You know, I did stuff like I used the same color wire for things. As far as being on a grid, I used for my basic layout the Aries system, which was on a grid. I had an Aries synthesizer in college, and I liked the way that it looked.
Right.
And so I said, well, I'm going to put it on a grid because that way I can have the same brackets, I can have the same pots in the same positions. I was doing it not for aesthetics, but I was doing it for the ease of people building it. That was my main thing, because what I didn't want to have happen is a nightmare of 400 emails a week. You know, I built such and such, and it doesn't work. So I tried to make it, you know, the phrase we like to use is, you know, idiot-proof. And
Right.
I think I did a pretty good job. I sold over 10,000 MOTM modules, and I probably had less than 50 ever come back.
Yeah, I was going to say that you must have been successful with it because of the number of things, the number of modules that you sold, and the fact that you still will talk to any of us at all. It's got to be difficult to do that, and I think that's a really interesting approach to making decisions. Now, the other thing, though, that I would say is that you set sort of a quality standard. And, you know, you talk about trying to keep the MOTM items reasonably priced, but they were still high priced. And some of it was because of decisions that you made on parts and decisions that you made in the designs so that you could have what I think you considered exemplary performance, right?
Right. Well, I think, you know, yeah, and it's again, you know, I wanted to have a system that would last for 20 years. Okay. When I was doing most of the design work, I was working for a telecommunications company that we sold equipment to, like, you know, to the Bell companies here in the U.S. And the requirement was 25-year life.
Right.
When they say when they say 25 years, they mean they buy it, they stick it in an underground concrete vault, and they don't expect anyone to touch it for 25 years. And I kind of wanted that sort of attitude for MOTM. Other people said I was over-designed, which I claim there's no such thing as being over-designed.
Right.
But yes, it was definitely over-designed. And part of it was in my career prior to that, when I was at Tandy, it was the opposite. Okay, so we would have meetings like, how can we save 5 cents? And I did, you know, and that's an art in itself. Okay,
Right.
doing things as cheap as possible. When I was designing cell phones at Research in Motion, we would try to save 5 cents over 1,000 phones. Not 5 cents a phone, 5 cents per 1,000 phones, because we made 35 million phones. Okay, so that's hard to do, but I was tired of doing that. So I wanted to be the opposite. I wanted to design something really where I wasn't that much worried about the cost. I really wasn't. In other words, if I could get a high-end military 0.1%, 10 ppm, RN55E resistor for 68 cents, I'd buy it.
Sure.
Because the other resistors were 5 cents, but this one was 10 times lower drift, 10 times more accurate, and I could. So I did.
Right.
All right, and that's why I chose switchgraph jacks. That's why I used, the pots I did. That's why I still use, the Alco Tyco knobs with the set screws and the brass inserts, because I wanted to show people that there was an alternative to building synthesizers that wasn't as cheap as I could do. And the reason I could afford to do that was I was not trying to make a living doing it, remember.
Right.
I was not trying to support my family with the MOTM. I was trying to buy a stereo.
Right.
That was the main reason, was I lived down the street from a very high-end stereo dealer, like I'm talking like $100,000 speakers and stuff.
Yeah.
And I wanted an entry-level high-end stereo, which was around $18,000. At this store, entry-level was around $18,000 to $20,000. And that's what I was trying to do. I wanted to get one of those high-end stereos.
I'm curious.
The speakers are so big, your wife won't let you have them in the living room.
Right. So I'm curious, what brand gear was it you were looking at?
The Mark Levinson 383 amplifier and B&W 804 speakers.
All right, sort of like the classic starting point for that. I'm fascinated. I mean, if anyone thinks that the modular synth world is filled with voodoo and magic, they just need to spend some time in a high-end stereo environment, because that is some outrageous stuff.
Right, and that's all another discussion about, at what point does the electronic reality stop and the voodoo start? But in the MOTM, you did mention, you want it to sound good. There are very specific things that you can do that are not voodoo magic. A lot of it is part selection, that you can just say, well, look, this part is going to sound better than that part. It's not really much of a debate. It's just the way it is. Or I can make a low drift VCO if I use these resistors versus those resistors, and that's not very much to debate. Now, a lot of people will still debate you about it, but those people don't have masters in double E.
Right.
Okay. Because the people who do have masters in double E, like Jürgen Hannibal and I, we never debated anything. Okay, so it's just like there's very specific things you can do. Like in my 440 filter, there's very specific things about why it sounds the way it is. And the Moog ladder filter, there's a very specific thing why it sounds the way it does. It's not voodoo or magic. It's very easily pointed out. Okay, you may not understand it if I point it out, but to me, it's very easily pointed out. So when I did MOTM, I decided to do what I call the anti-candy. Okay, I did not look at the bill of materials when I decided. I said, what is the best op amp for this job? What are the best capacitors and resistors for this job? And then I just took the price and doubled it, and I sold it.
Right. Well, it's my first experience actually touching one was at the NAMM show, when you were there and you had a big system, and I have to admit it was just a stunning experience to put the headphones on and to play around a little bit. Robert was working the booth with you on that one, and it was an amazing thing, because prior to that I had cobbled together modular gear by whatever broken down university piece or old artist's 20-year-old system that had sat in its garage. I kind of just like cobbled together a modular system from that. And then I'm hearing about the MOTM stuff, but I didn't jump on board right away. And then I was at the NAMM show, and I was like, holy crap, this is, first of all, it's really nice that it's new and it works and it's stable as hell and it sounds great, but everything about it just felt wonderful, and it had a personality, and just in the way that the the jacks plugged in and the way that the knobs turned out. I was just amazed. And frankly, I remain amazed at the work you're doing. For example, I'm looking at I have a small Eurorack system I use when I'm doing performances, and I have an E440 filter in there, which my claim is that it's the best filter in Eurorack by a long distance. It's a wonderful piece of work. And so over this whole period of time, these 13 years that you've been working on this stuff, you sort of maintain that, even though when I look at what's behind the panel on an E440, it's very different from what's behind the panel of, say, an MOTM 440, right?
Yeah, sure. And that's because, again, the parts aren't available anymore.
Right.
And so there's a prime example about knowing. I mean, I have very intimate knowledge of that circuit that, Jürgen Hagel, originally developed and licensed to me.
Right.
And so when the original parts that are in the MOTM version became unavailable about 2.5 years ago, it took me about 10 months off and on to find an equivalent set of parts that sounded the same. I mean, it was not easy. It wasn't just, pick that. No. It was building, 8 or 9 different versions of it and having different people listen to it and say, no, that's not it. No, that's not it. Oh, God, no, that's not it at all. So it was very difficult to find the right combination. Okay. And I knew, for example, that I had to use the same capacitors. The capacitors that are used in the 440 filters are polystyrene, and if you change out those capacitors, it will sound different.
Oh, really? Okay.
And so I had to use, and if you look real closely, those are hand soldered on the board. The rest of the robots, those are hand soldered, and it cost me $1 a piece for those capacitors, but I don't care. It's what makes it's what a big part of that sound is, are those capacitors.
Right.
And the rest of it is getting the gain structures matched and the OTAs, and that took a long time to do. The parts that were in the original MOTM 440, they were very expensive parts, but they were very accurate. And those parts are no longer available, so I had to go to cheaper parts. They're cheaper, but they're not as accurate, so I had to do a lot of experimentation. And so that's an example of having the original design go obsolete and not say, well, I can't build 440s anymore. Whereas if I didn't know how that circuit worked, that's what I would have to say.
Right. That's where knowing.
Right, but I know how it works, so I know what to do, so I just have to do the work. I'm doing that same thing right now on the Yamaha CS80 filter in MOTM, the 480, which uses the CA3280, which you can no longer get. So me and the original designer are working to build it again with completely new parts, but we have to make it sound the same, but we know what the trick is. Okay, there's actually 2 tricks to make it sound the same, and so we have to replicate those tricks in the new design. And that's going to take some time, and I'll probably have that out this summer. But it'll sound just like the original 480 when I'm done, but it won't be the same schematic at all.
Well, now this raises another question, though. Some of the other modules that you're doing, particularly on the Eurorack side, are actually computation devices that you have performing audio functions. I'm thinking of the morphing terrarium, the dual LFO, morphing LFO, the cloud generator. These are computational devices, right?
Yes, they're all based on DSP, circuits on the board.
Right. I have to try and figure out how to word this the way I want to word it, because I don't want to sound prejudicial one way or the other. I think it's cool that you can do it. But to what extent did you make the choice to do this DSP based stuff just to make it practical versus preventing running down a road where parts would no longer be available? I mean, is it something where you said, hey, I want to do sine cloud generator, and there's no way to do it realistically in, analog hardware? Or do you not think about it one way or the other? That's kind of convoluted, but I hope you can
Right.
understand what
Now I
I'm
understand
saying.
what you're saying. Well, okay, I'm going to say something that's going to sound kind of arrogant or strange to a lot of people. But again, if you're a double E, you'll know what I'm talking about. There's only so much you can do with resistors, capacitors, transistors, and op amps. There's only so much you can do. And most of it's already been done. There's not going to be any new filter discovered because all the filter transfer functions are known. It's like discovering a new element between 12 and 13.
Right.
There's not one. It's either 12 or 13. There's not a 12 and a half. Okay. And that's somewhat true in analog design, is that it's been a focus for so long, since 1968. It's been a focus. And there's really not much room left for pure, true, never before seen, completely unheard of, oh my God, analog thing. Okay?
Right.
But in the DSP world, we're just in the first 5 years of a 30-year adventure in DSP.
Right.
So we're basically, in the DSP world of things, we're in 1972 right now. That's where we are. We're in 1972 electronics, if you think in terms of what we can do with DSP. The thing about DSP is, again, up until 3 or 4 years ago, it was very expensive. The parts were only on ball grid array, and most people can't deal with ball grid array. They consumed a lot of power because they weren't concerned with being, power efficient. But we've all benefited now from the iPhone revolution and the cell phone, smartphone revolution, which is all DSP based. And so now that's the main consumer driver. Okay, I mean, what is the electronic consumer driver in the world? It's cell phones.
Absolutely.
It used to be computers. It was computers for 20 years. Before that, it was home stereo. It was the home stereo. Was the home stereo and color TV, I guess.
Right.
Were the drivers. Okay, but now the driver is cell phones, and the cell phone is 99% DSP. That's the driver. So what happens from the fallout from the semiconductor companies is you start putting more R&D into DSP. Well, the thing about DSP is that even a low-end cheap DSP, I say cheap, I'll say a $5 chip. So let's talk about what's in the 350 and the 340. Okay, it's a microchip, $5 part. Okay, that $5 part is running at 72 megahertz, running 16-bit calculations, and sometimes 64-bit calculations, 72 million times a second for $5. That's pretty impressive to me.
Yeah.
Okay, because the way DSP works is you have to do all your calculations between your sample times. So if you're going to have a sample rate of 44.1 kilohertz, okay, what does that mean? We have like 22 microseconds to do all your computations. Well, that doesn't sound very much like time. 22 millionths of a second? That's much time. Well, the thing is you can run 100,000 calculations at a time. And you can do a lot with 100,000 calculations. So that's the advantage. Now, it's very difficult to learn. It's very difficult to what's called an abstraction level, which means how can I look at a bunch of mathematical equations and make a morphing terrarium come out at the end? Okay. Again, years of learning to do that. You just don't pick up a book and read it in a weekend and become a DSP expert.
Right.
Okay. And so you just have to tell your, to learn how to do this kind of stuff. Things like, you said, the computational, engines. So if you're doing oscillators, that's a computation, all right? And it turns out to do a simple wavetable oscillator is a very simple, fast computation. like the current morphing terrarium has two outputs, right? Has an X and
right.
Y as the output. So I did an experiment and saw just a pure software experiment where I said how many different outputs could I compute in a morphing terrarium? 280. So if I had the hardware, I could have 280 individual outputs in a morphing terrarium for a $5 chip.
That's just stunning. Yeah.
So here's the deal. This is what's unusual. Because the driver is cell phones, which is battery powered for one. Okay, think about cell phones. Battery powered, your tablet's battery powered. The world has gone away from things that plug in the wall to being battery powered. It leaves the old technology behind because the old technology is on a 36-volt process. It's designed, plus or minus 15 or plus or minus 12 volts. There's not plus or minus 15 volts in your cell phone.
Right.
Okay? If you're lucky, you have 3 volts. Most cell phones run at 1.8 volts. Some of them run at 0.9 volts now. Okay? You don't have plus or minus 15 volts in your cell phone. Well, if you look at all the new op amps that come out, what do you think the new op amps run on? They run on plus or minus. They run on plus or minus 15. They run on 3 volts.
Yep.
Okay. Are they nice big dip packages? No, they're teeny weeny packages. All right. So we have to use what's available to us at the era that we're designing in. And right now, the era that we design in is this older stuff is slowly going away. Okay. Just to give you an example, a really good op amp, okay, that is good for both audio and DC, and quantity 1 right now is $6. So I can get an op amp for $6, or I can get a whole DSP for $5.
Yeah, that's right.
And the pots I use cost $2.50 each, okay? So I can get a whole DSP for the price of 2 pots.
Right.
And so the cost of analog is going up in the older technology, okay? If you want to stick to the old technology, if you don't understand how to move from designing from plus minus 12 volt systems to 0 to 3.3 volt systems,
right?
Okay, then you are forcing yourself to use a subset of available parts in the world, which happen to be the most expensive parts in the world. And so part of the reason I'm doing this is to train myself to move away from the older technology. Okay, like in the E370 quad VCO I'm coming out with, working on, all the op amps are low voltage op amps in there. Okay, they're not the old technology op amps. I'm moving away. It has a 120 megahertz DSP in there.
And then you're just moving the voltage up at the last step for interfacing with the rest of the system?
Yes. Then you just have to goose it up at the very, very end.
Right.
Okay, but all the internal processing is all done at 3 volts. Everything on the board is 3 volts, except the very stuff coming in and the very stuff going out.
Sure.
Okay? And so there I'm forced to use old technology op amps, okay, and which you can still get, but they're not near as good as the newer technology op amps that are single supply. They're just not as good. And that's because the companies that make them are no longer focusing on that market. The companies like Analog Devices and TI that make these op amps,
right,
they don't sit around and say, we need to make the world's best plus or minus 15 volt op amp. Because Apple is like, now we want this other low voltage op amp, and by the way, we want 10 million a week.
Right.
10 million a week. And the other high voltage stuff, they sell 10 million in a year.
Right, right.
So that's part of the deal is, and so you have to always evolve. I mean, that's one of the reasons I think I've done so well in my career is I've always trained myself about every 5 years to do something different. Okay, and it's hard to do. It's hard to let go of the old stuff because you become familiar with it. But I know a lot of people who just like in their career that just stop and say, I don't want to learn DSP.
Right.
I don't want to learn to program in C. I had a discussion recently with somebody who wanted to do something, and I said, well, that's a perfect thing for a little microcontroller. He goes, well, I don't know microcontrollers. So what do you think I told him? Learn.
Yeah, get a book.
Learn. Okay? Because he was thinking, I can do this with a bunch of 555 timers and maybe a phase lock. I said, look, you're wasting your time. You could do it with a microcontroller and 20 lines of code.
Right.
So sometimes the solution is right in front of you, and the excuse that you don't know it, to me, is not an excuse. You learn it. That's what I've done.
Right.
Okay. Remember, I'm a chemistry major. I knew all about pH calculations. I didn't know about crap. Okay. And so, in my job at work, I wasn't that familiar with programming in C. I was an assembly language programmer. Well, every day at my work, I program in C and nothing but C.
Right.
And so I've had to learn. So at the age of 58, I'm taking C classes, which is interesting because my teacher's 27. So.
Right. I hear that.
But he knows C and I don't. So there you go.
Well, Paul, man, I've got a list of questions I'd like to ask that's as long as my arm, but unfortunately our time is up. I'm going to be coming back to you for a follow-up on this because I think you've given us some incredible ideas, some just sort of like core knowledge, and getting it from you is like magical. I really appreciate the time, and I'm gonna get back to you so we can follow up on this a little bit at some point too, if that's okay with you.
Sure, we'll have parts 2, 3, and 4 coming up this summer.
That sounds fantastic. All right, thank you very much, and have a great day.
You too. Thanks. Bye.
Bye. And there's another one in the bank. A lot of times, Paul likes to sort of self-identify as a bit of a curmudgeon, but he, in fact, is one of the most open and willing to share people out there. So I hope that you enjoyed the interview as much as I did. As always, please do me a favor and share this podcast with your friends or even with your enemies, because maybe we can scare them into behaving. But in any case, let's get the listenership up. If you have any ideas on people who should be interviewed, or if you yourself want to be interviewed, just drop me a line. As always, my email is ddg@cycling74.com. Otherwise, thanks a lot for listening, and we'll catch you next week.